Hi guys, I'm Nivita. In this video, we are going to discuss about series of real numbers. Okay, so basically in last video we have discussed about sequence. Sequence means 1 comma 2 comma 3 comma 4. It comes like comma comma. Okay, here we are going to see about series. Series means summation. Okay, 1 plus 2 plus 3 plus 4 up to. In last video we have seen like whether that sequence convergent, that sequence divergent. Okay, so now what we are going to see is, suppose 1 plus 2 plus 3 plus 4, the addition of numbers. Okay, the addition of numbers will be converging to a particular number or not. Like that concept we are going to see. In last video we have seen like 1 2 3 4, this particular sequence converges to a limit or diverges. Here we are taking that addition of those numbers, and we are going to find whether that particular number is going to converge into a particular number or not. Okay, series a and b, the sequence of a real numbers. The expression a1 plus a2 plus an is called the infinite series because it goes on, right? And it is denoted by summation n equal to 0 to infinity an, or simply summation an is also represents the infinite series only, and an is called the nth term. With the summation an, the sequence of partial sum. Okay, we are going to see sequence of partial sum, meaning suppose if you are considering a sequence. Okay, that sequence is summation k is equal to 1 to n ak. You are considering up to one particular term. You are considering up to one particular term, not up to infinity. Okay, so see here, Sn is equal to summation k is equal to 1 to n ak is called the nth partial sum of series. If Sn converges to a particular number, the series convergence. Okay, write summation n equal to 1 to infinity an is equal to s. S is called the sum of the series. Okay, suppose Sn diverges, that particular series diverges means then that series also is said to diverge. Okay, sometimes see here, Sn means partial sum. Okay, suppose you have to you have to add so many values up to infinity. Okay, up to it goes on up to infinity. You are considering some subsequence like this. Suppose if this addition goes to infinity, then that whole sequence will goes to infinity. If this sequence converges at a particular point, okay, you are considering a subset of that sequence which is known as subsequence. So if that subsequence converges to a particular point, then the whole sequence also converges to a particular point. That is the concept behind sequence of partial sum. Next, necessary condition for the convergence of the sequence. There are some conditions. See here, summation of an convergence, then limit n tends to infinity, an is equal to 0. Suppose if you want to say that a series is convergent, okay, that a series is convergence means you can automatically says limit n tends to infinity, an is equal to 0. You are applying the limit. Okay, that when this converges, when this summation converges means that limit n tends to infinity, a equal to 0 will come. An tends to 0 is not sufficient to ensure convergence. See, tends to means what? Approaching. Approaching means it is not reaching 0, it is approaching, it is coming. Okay, so in approaching 0 is not sufficient to ensure convergence. Okay, for example, summation k is equal to 1 to infinity 1 by n you are considering. Here you are considering summation. Okay, it's like 1 by infinity is equal to 0, right? But it is approaching. Okay, this sequence is approaching to 0. Approaching means before reaching 0 there are infinitely many numbers are there. You have to add all those numbers. Understood? So that type of series is divergent. Okay, suppose if an converges to 0, converges to means like it is approaching to 0 means it is a diverging sequence, it is not a converging sequence. Okay, then limit n tends to infinity, an not equal to 0 means summation of an cannot converge. See, this is the thing. Suppose if this value not equal to 0 means then summation of an cannot converge. Understood? Then a series of non-negative sums converges if and only if partial sum form a bounded sequence. I already told you, right? The non-negative term, suppose if you are considering a sequence, okay, it is said to be converges. You have to take some partial sum, okay, which is a subset of that sequence. Partial sum forms a bounded sequence. Okay, bounded means it should have some lower point, upper point, like that. Next we are going to see geometric series. Geometric series means 1 plus x square, it goes on. So t2 by t1 is x square by x is x. So like what to say, t2 by t1 is equal to t3 by t2. Like that it comes, means it is geometric series. When you are going to find the addition, okay, when you are going to find the addition, it converges if modulus of x is less than 1, diverges if x is less greater than or equal to 1. Okay, you are considering this x value. Okay, you are taking modulus. If that modulus is less than 1, means it converges. You are considering the value of x if it is greater than or equal to 1. Okay, when it is greater than or equal to 1, for example 2, 3, 4, 5 and all, no, so it comes like 2. Then it's like 2 square is 4. So like that, when it comes, no, it diverges. Oscillates finitely when x value is equal to -1. When it is equal to -1, it oscillates finitely. When it is less than -1, it oscillates infinitely. Understood? Next, telescopic series means what? See here, b2 minus b1 plus b3 minus b2 plus up to bn plus 1 minus bn. Okay, suppose if this type of series comes, means we can easily cancel this b2 and b2. Understood? Likewise, next term will be like b3 minus b2 comes, right? So b4 minus b3 will come. This two will get cancelled. Next terms will get cancelled. Finally, what you will get is bn plus 1 minus b1 will come. This is known as telescoping series. Okay, so a and b the series of real numbers. What is the condition? Bn plus 1 minus bn, which means b2 minus b1 plus b3 minus b2. Likewise, when used to come like that, no, so it is known as telescoping series. Understood? So series means addition of numbers. This is also one of the telescopic series. You can ask like how it is a telescopic series, but if you find partial sum, like you have to consider it like a divided by n plus b divided by n plus 1. Understood? So after finding the value of ab, you will get what? You have to take this value, 1 is equal to a into n plus 1 plus b into n. When you are putting n is equal to 0, you will get like a value is 1. When you put like n equal to minus 1, you will put get the value like b is equal to minus 1. When you substitute here, you will get like 1 by n minus 1 by n plus 1. Understood? So it is also a telescopic series because alternating plus minus next terms will come. Understood? Next, test of convergence. Let's see one problem and then we will wind up like a P series test. Say test for convergence, to test whether that series is convergent or not. Okay, a positive term series summation of 1 by np is convergent if and only if p greater than 1. See, summation 1 by np, here we are having one value p. When this p is greater than 1 means, okay, that particular positive term series will be convergent. Positive term series means it contains only positive term. Okay, that positive term series will be convergent only if this p greater than 1. Summation 1 by np is called hyperharmonic series or p series. This particular type of series is known as hyperharmonic series or p series. Okay, example for this is 1 by 1 power p plus 1 by 2 power p plus 1 by 3 power p. Likewise, if this p greater than 1, it converges. If this p less than or equal to 1, it diverges. Okay, you can make a tabular column and then you can like click p test and the format and how when it converges and when it diverges. So it is, you can also see in this problem summation n equal to 2 to infinity 1 by 2 log n power p. Okay, here also we are having p converges if p greater than 1. Suppose if you are given the value like 3, then it is converges. Okay, value like less than or equal to 1 means for example less than or equal to 1, you can consider 1 itself. Suppose if the power of the value of p as 1 means, then it will be a divergent sequence. Understood? So this is p test. Then we are going to see comparison test. Summation of an is a positive term series, that is very important. This comparison test series, everything will be applicable to only positive term series alone. if an is less than or equal to cn, for n less than or equal to a naught is some fixed integer, summation of an converges, then summation of an summation of cn converges, then summation of an converges. See, there is one sequence. Okay, here also there is one sequence. This sequence is less than or equal to this sequence. Okay, so take one particular value of n which is less than or equal to n naught. N naught be some fixed number, for example 10. Okay, so when you have to consider this value of this value which is a natural number. Okay, but that should be less than the 10. Okay, suppose if you are taking one particular sequence, okay, one particular sequence, that sequence is less than or equal to another sequence. Okay, suppose if this sequence series, if the series of this sequence cn is convergence means, then automatically this series will be converged. Okay, then if an is less than or equal to cn and n less than or equal to an, if summation of an diverges, then summation of cn diverges. If this summation diverges, then this summation diverges. If this summation converges, this summation converges. Understood? So it is applicable to only non-negative an. Okay, let's see. Summation of e power minus n square is convergent. Okay, so we all know like e power n square is greater than n square. Basically, exponential means it is very like what is the increasing function. Okay, so e power n square is greater than n square. Okay, when you are putting it in denominator, you have to change the sign from greater than to less than. So 1 by e power n square is less than 1 by n square will come. So this e power n square, when you are bringing it to numerator, you will get like e power minus n square is less than 1 by n square. Okay, so see here, this is convergent because 1 by n square is convergent. How we are telling 1 by n square is convergent? This is in the form of p test, right? The power of n is 2. 2 is greater than 1. When the value of p is greater than 1, it converges. Okay, so I am telling that 1 by n square is convergent. See, e power minus n square is less than 1 by n square. Suppose if this series convergence means obviously e power minus n square series also convergence. Okay, so summation of e power minus n square series will also be a convergent. Okay, fine. Next we are going to see a limit form test. Summation of an, summation of bn are the two positive term series. Limit n tends to infinity, an by bn is equal to L. Finite or non-zero number is existing, then both series behave alike. Okay, see, there are two sequences. Okay, suppose if this condition satisfies means they both will converge together or they both will diverge together. You can tell from one sequence it is converging means automatically by using this particular thing you can tell like okay, it converges together, it diverges together, so you can automatically tell this sequence also converges, like that you can tell. Okay, so the both series behaves alike for a limit form test. Okay, that is both converge or diverge together. Check the convergence and the divergence of the series summation 1 divided by n power 1 by n 1 plus 1 by n is equal to summation of an. Okay, so what I have to take is I'm going to take 1 by n as summation of bn. Okay, I'm going to consider 1 by n as summation of bn. So take limit n tends to infinity an by bn. You will get with what? This is your an value, summation of an. So don't take summation, just put 1 by n power 1 plus 1 by n divided by bn value is 1 by n. Okay, when you are bringing this to numerator, this power is 1. Okay, so when you are bringing this to numerator, you will get like minus 1. Okay, so plus 1 and minus 1 will get cancelled. So limit n tends to infinity, 1 by n power 1 by n will come. Okay, when you are putting infinity, 1 by infinity will give 0. Anything by 0 will give you 1. 1 by 1 will give you 1, which is not equal to 0, comma infinity, right? So what you can tell is by the comparison test. So here what you are getting, limit n tends to infinity, an by bn is equal to finite value. Then that series behave converge or diverge together. So you can tell like summation of bn and summation of an converge or diverge together. But you know like bn is divergent. Bn means what? 1 by n, means you have to take all the sum of the series. I already told you, right? In here somewhere we have seen like summation k is equal to 1 to infinity 1 by n series is a divergent series because it is approaching to 0, not equal to 0, right? So we know that this particular sequence is diverging, so automatically we can tell that summation of an also diverges. Okay, then we are going to see root test. So here summation of a and b a positive term series. Okay, so alpha is equal to limit n tends to infinity supremum of n root an. Then see those conditions. When alpha is less than 1, summation of an converges. When alpha is equal to 1, test fails. When alpha is greater than 1, the summation of an diverges. Okay, alpha here is limit n tends to infinity supremum of root of n a power n. So when we have to use this root test means, suppose if you are having a value in the power, in terms of power, you have to take root test. Okay, so check the convergence or divergence of the series summation of an, where summation of an is equal to summation of 1 by 1 plus root n to the whole power minus n power 3 by 2. This is the value of summation of an. Okay, so take that value of an like this. Okay, then what we are going to do is just bring that numerator to denominator, then this minus will become positive, right? So you can take like 3 by 2 as 1 plus 1 by 2. You can take 3 by 2 as 1 plus 1 by 2. You can separate this like n into n power 1 by 2, because this is n power 1 into n power 1 by 2 you can write, right? Okay, then we are going to consider this. So this is your an. You are going to put 1 by n here. You are going to put 1 by n here. Then you are going to take that supremum. Okay, limit n tends to infinity supremum of an power 1 by n you have to put. So then what will come? Limit n tends to infinity supremum of, this is your supremum value. Okay, for this you have to take to the whole power 1 by n. You have to take to the whole power 1 by n. Here also 1 by n. What will come? This n will get cancelled. Understood? So what you will get is 1 plus 1 by root n to the whole power root n will come. Okay, to the whole power root n will come. See here, I already told you one thing, that I already told you one formula, which is where it comes. See here, limit n tends to infinity 1 by 1 plus n to the whole power n. Here also same value comes, means that value is e. Okay, here also same value coming, so that value is e. So 1 by e. 1 by e means it is less than 1. Okay, so L is equal to 1 by e, which is less than 1. So what we have seen, when the alpha is less than 1, that summation of an is convergent, right? Therefore this summation of an will be convergent. Understood? Yes. Then we will see next videos later. Thank you for watching. If you like this video, please like, share and subscribe to my channel. Thank you.